Really, the whole point of this section of the exam is to see if you can build truly robust defenses. We're talking about taking these high-level security ideas and mapping them directly to the specific Google Cloud services and settings that make them a reality.
First up, let's talk about building the walls of your fortress. Designing perimeter security is all about stopping threats in their tracks before they even get a chance to come knocking on your application's front door. So here's the key takeaway. You really need to think of perimeter security like a medieval castle's defenses. You've got this big, high wall, that's your basic filter, and you've got a really vigilant gatekeeper checking every single person who tries to get in. It is your first, and honestly, your most important chance to block the bad guys.
Now, what's really cool is how Google Cloud handles this. It's not just one thing, it's a two-step process. First up, you've got Cloud Armor, which is basically the bouncer at an exclusive club. It's looking for known troublemakers. Things like DDoS attacks, SQL injection, all that nasty stuff. Then, you've got the Identity Aware Proxy, or IAP. Think of IAP as the bouncer who also has a very strict guest list. It doesn't just look for threats, it checks who you are to make sure you're an authenticated user who's actually allowed inside in the first place. And this right here, this is a perfect example of how powerful these modern tools are. Just imagine an e-commerce site getting hammered by a credential stuffing attack. Instead of engineers scrambling for hours, Cloud Armor's AI-powered adapter protection spots the weird traffic, suggests a fix, and an engineer can approve it with just one click. The time to fix the problem drops from hours to literally under 2 minutes. That is a total game changer.
Now, for the exam, you're going to have to go a bit deeper than just Cloud Armor and IAP. You need to understand how the Cloud Next-Gen Firewall gives you that deep packet inspection right at the edge. You need to know how the Certificate Authority Service can lock down machine-to-machine traffic with mutual TLS. And you should know how the Secure Web Proxy controls what your users are accessing on the way out. All these tools work together to build a really tough, layered perimeter.
But look, a strong outer wall is never enough. A core principle of modern security is defense in depth, and that means you have to assume your perimeter will be breached at some point. So that brings us to boundary segmentation, basically building walls inside your network to stop an intruder from running wild.
So how do we stop an attacker who somehow gets past that main gate? Well, we build internal compartments. By isolating our services and controlling access at the API level, we stop them from moving laterally. This is huge. Even if they steal valid user credentials, they're basically trapped in one small corner of the system, unable to get to the really important stuff.
So how do we do this in practice? Well, this slide shows 3 of the most important tools in your toolkit. You use a private IP for your Cloud SQL databases so they're never, ever exposed to the public internet. You use VPC service controls to build a virtual perimeter around your Google APIs. And if you're using containers, you use GKE network policies to control traffic between individual pods. It's all about layers. Okay, everyone pay close attention here, because this is a concept you absolutely have to nail for the exam. It's a bit tricky. IAM controls who can access your resources. VPC service controls, on the other hand, dictates from where they can access them. A hacker might steal credentials, that solves the who problem for them, but VPC service controls will still slam the door shut if they're trying to access it from outside your trusted network.
You will almost certainly see a question about shared VPC versus VPC peering. The difference can feel a little fuzzy, but here's a simple rule of thumb. Shared VPC is all about central control inside one organization. Think one network team managing everything. VPC peering is for connecting independent networks that need to talk but also need to stay separate, like if you're working with a partner company.
And this brings us perfectly to a classic exam scenario, the N-tier architecture. You've got a web tier facing the internet, an application tier that can only be reached by the web tier, and then a data tier that can only be reached by the app tier. The key to making this work, the secret sauce really, is using network tags to create super specific firewall rules that enforce this strict one-way flow of traffic. Okay, so we've built our outer walls and our inner compartments. Now we have to think about the secure hallways that connect everything. This is where private connectivity comes into play. It's all about making sure that all the communication between your workloads and with Google services is totally locked down and secure. The guiding principle here is really simple. Keep traffic off the public internet whenever you possibly can. By routing everything through your private VPC, you prevent accidental exposure of your internal services, and you can inspect, log, and control all the traffic that's leaving your network.
So here's a really common challenge, and I'd bet you'll see a question like this on the exam. How do you securely control the outbound traffic from a serverless service like Cloud Run, which by default just sends its traffic straight out to the internet?
And the answer is direct VPC egress. By setting the egress to all traffic, you force every single outbound request from your Cloud Run service to go through your VPC first. And this is so powerful. Let's say you need to call a payment gateway that requires a static IP for its allow list. Well, now you can just route that traffic through a Cloud NAT to get that static IP. Problem solved.
Now, for reaching Google's own APIs from your internal workloads, you've got two main options. Private Google Access is the simpler one. It lets your VMs reach those APIs without needing public IPs. But for the exam, remember this detail. To make it work with VPC service controls, you have to use the special restricted.googleapis.com endpoint. Private Service Connect is even more secure. It literally brings the API endpoint directly into your VPC, making it look and feel just like another internal service.
And finally, a few more connectivity tools you'll definitely need to know. For connecting securely back to your on-prem data center, you've got HAVPN for an encrypted tunnel, or Cloud Interconnect for a dedicated physical connection when you need massive bandwidth. And like we just saw, Cloud NAT is your go-to for letting your private resources safely make outbound connections to the internet.
Okay, we have covered a ton of ground. So let's take a breath and boil all of this down into the most important takeaways you need to have locked in for Section 2 of the exam.
If you remember nothing else from this explainer, please remember these 3 principles. Number 1, layer your perimeter. Don't just rely on a firewall. Combine it with strong identity checks. 2, segment your internals. Assume a breach is going to happen and build walls inside your network to contain the damage. And number 3, default to private. Make private connectivity the rule, not the exception. So I'll leave you with a question to chew on as you study. When you're designing your next system, which of these layers do you think is truly the most critical for stopping a modern data breach? You know, there isn't a single right answer, and understanding those trade-offs, well, that's the key to becoming a real security pro. Thanks for joining me, and good luck on your exam.